Students, can you see the screen? Good. So today, inshallah, we'll take chapter number 5 and chapter number 6. That is methods and arrays. Fine. It's good. You can see the screen. Let me share this screen. I think you can see the screen, right? Thank you. So, 2 chapters, inshallah, we're going to take today. One is chapter number 5, methods. The other is chapter number 6. It is arrays. Okay, let me put this on recording. So, the objectives of this chapter number 5 is to give you an idea and explain you about arrays, the methods, which are static methods and non-static methods, right? So we'll see like what are these methods and where we can use these methods, how methods will help us in solving the problems or in programming, right? And then we're gonna see the 2 ways to pass the values to the references. That is, when we write any method, right, we can pass the values to the methods. So we'll see like what are these 2 ways to pass the values to the methods. Okay. Then we'll talk about method overloading. What is method overloading? Okay, we will discuss about this. So these are 3 main objectives of today's discussion. Introduction to the methods. In object-oriented programming, the objects are used as building blocks in developing a program. We have seen that when we write a C# program, it's a class, right? So in object-oriented programming, we write the classes. Inside the classes, we write the methods. Like we wrote the methods, we have the method, the main method, right, which is a static method. Similarly, we can write our own methods. We can write a method to add 2 numbers. We can write a method to multiply numbers. We can write a separate method to find the area of circle, find the area of square or a rectangle, and so on, right? So when these methods are created inside a class, and if we want to use these methods outside the class, we create objects of the class. We create objects of the class. And once we create objects of the class, we can call these methods. Yeah, do you have any question? The screen is shared. How about the other students? Can you see the screen?
Yes, we can see the screen.
Yeah, we are in introduction slide. Can you see that introduction slide? Right? So Amina, can you just please re-log in? I mean, I think you have problem from your side. Okay, fine. So, so we can create the methods and we can call these methods wherever necessary to you make use of those methods, right? So objects can be created to make use of these methods, but for now we try to understand what is a method, and we are not going to look inside the objects like how we create the objects or how we are going to deal the objects with the objects, fine. So now when we create these objects, right, object encapsulates data and code to manipulate these data. And the code is designed to work on data, which is known as methods in C sharp. That is whatever the code we are gonna write to work on the data of the class, right? For example, let's say that we write a class called a student, and the student has some data, right? For example, student ID, student number, sorry, student name, student email, and student marks, courses, and so on. And we write different methods in this student class for different purposes. We may write a registration method, we may write an calculate GPA method, and so on. So when we create objects of the student class, for example, student Ahmed. So we create an object of Ahmed. Ahmed has its own data of ID, name, email, courses, GPA, and so on. And Ahmed can call the methods like registration, calculate GPA, and for example, print the transcript, these methods. Similarly, when there is another object, another student, for example, Abdullah. Abdullah is an object now, which is a student object, has its own data. And Abdullah can call these methods, registration, calculate GPA, print transcript, and so on. So these methods work on the data. For example, to calculate GPA, the method GPA takes the student registrations in the courses, their score, and calculate the GPA. Right. So the codes are written in a methods for every action, for every task. Right. So we can divide the task by the methods. We can divide the tasks by the methods. Okay. So method gives object their behavioral characteristic. That means method helps the objects to do some task, to do some job. They are used not only to access and process data, but also to provide some response to any message, any other messages received from the other objects. A method is a group of statements that together performs, and in every C# program we have at least one method, which is the main method. So that we have seen that before, that every C# program, for example, here I have the main method, right? So every C# program comes with this main method. Main method is the one where we start the execution of the program. Okay. C# is pure object-oriented language, and therefore method must be contained within a class. The main method must be within a class. Now declaring methods in C#. Declaring a method inside a body of the class, the general form is that you write the access modifier, the return type of the method, the name of the method, and the parameters, the formal parameters of the method, and you open the bracket and close, and that forms the body of the method. So if we look back here, we have the access, we have this the static void main, the arguments, and this becomes the body of the method. Okay. Apart from that, we can also mention the access modifier. Now, what are these access modifiers and why we need these access modifiers? Access modifiers help us to define what permission we have to access these methods. Some methods are public in the sense we can call these methods anywhere from the class. If the methods are public, these are public method in the sense you can call these methods from anywhere. Some methods are private. These methods work only inside the class where you write these methods, where you declare and define these methods. Whereas public methods can be accessed outside the class, anywhere you can access. Once you create an object of that method outside the class, the object of the class outside the one class, you can access the methods. We also have something called protected and internal. Protected is you can access a method within a class and its subclasses when it comes to inheritance. In the sense, a class can have its subclass. It's like father and child. So a father class can have a child class. So a superclass can have a subclass. Now, if there is a method in the superclass, we can access this method in the subclass if it is protected. If it is private, no, we cannot access. If it is public or protected, we can access. And internal, within the assembly of the class, within that project of the class, we can access the methods which is defined as internal. So first word in defining the method is the access specifier or the access modifier, whether it is public, private, protected, or internet or the internal. Okay, so this is the first part or in the method header. This is what we call it as a method header. Okay, which we have access modifiers. So access modifiers can be public, private, protected, internal. Basically, we use public when we want the methods to be accessed from anywhere. Sometimes we use private when we want to keep a method private and within the class itself, and we don't want anyone to access this method outside the class, whether by creating the object or not creating the object. Sometimes we want to keep them protected so that it will come only in the class hierarchy, father and child class and so on. That is the superclass and subclass. And sometimes we want to keep internal to be accessed within the project. So this is what is an access modifier, right? The first thing. Then we have a return type. Return type is a method may return a value. If a method is returning a value, know what type of value it is returning, whether it is returning an integer value or a float value or a double value or a string value or a character value or a boolean value, what type of value the method is going to return, that we have to specify. And we can see that in our method, in the main method, it is said void. Void, it means the method does not return any method. You don't see any return here, right? You don't see any return here. So that means that this method does not return any value. But when we have some return type, for example, integer as a return type, this method must return some value. You can see that program main, not all code paths return a value. That means this method is not returning a value. Now I have to return some integer value, for example, return 0. Now it's okay to write int and we have a return an integer value whether it is 0. Okay. And what if my method does not return any value, I just mention void saying that this method does not return any value. It executes when we call this method, but it does not return any value. That's what it means here. So return type can be any data type here, for example, int, double, or it can be a void in case that your method does not return any value. Then comes the name of the method. This should be a unique and it is case sensitive. You have to take care that the method, what case you are using, the same case you have to use when you call the method, when we use this method. Okay, it cannot be same as any identifier declared in the class. For example, you declare a variable sum and you cannot write the same sum in the name of the method, right? Because you already used that sum for another purpose. So sign and try to keep the method name meaningful names. For example, you are calculating you're writing a method to calculate area of circle, right? So what you name this method? You name it area. So area of what? So you can name it like area of circle. Okay, one word without any space. Or you can name like area underscore circle, right? So or area to circle. Something which is meaningful. When we see the name of the method, we can understand that what does it happen, what does it do. Okay, this is a recommendation, right? Recommendation for a good programming skill, that you use the names of the identifiers which are meaningful names for the variables, for the names of the methods, for the classes and all. Okay, so method name is again a unique identifier to identify the methods and to call these methods. We use the name of the method. Whenever we want to call a method, we are going to use the name of the method to call these method. Okay. Then we have a formal parameter list enclosed between parentheses. Now these parameter list are used here to pass any value to the method when we call the method. For example, we want to write a method called to find the area of circle. Now what we want to find the area of circle, we want the radius, and we want to pass this radius from the main method to the area calculate area method as a value. Then we can write that here as a parameter, that this parameter takes a value, okay, and these values are taken into the method inside the body of the method and performs the calculations, whatever. So the parameter list refers the type, order and number of parameters of a method. So you have to specify in order. For example, if you have more than one parameter, it cannot be, it is not necessarily like it is only one parameter. It can have more than one parameter, or sometimes we can have no parameters, zero parameters, right? And we can have different types of parameters. We can have integer, we can have characters, we can have strings, we can have arrays. Okay, different types of parameters we can have, and different numbers we can have. For example, 2 parameters, 3 parameters, and not necessarily that all parameters should be the same type, all should be int. No, can be all int, it can be one int, one double, one float. It depends on what is the requirement of the method body that needs to perform the operation. Based on that, we are going to specify the parameter list. And when we call the method, and we are going to pass these values to the method as a parameters, as in parameters. Okay, so we also see that there is a main has a string array parameter. You see this is a parameter, okay, of type his name is argument, it is of type string and it's an array argument, right? Array parameter. Fine. So in this we can specify different type. When we write our own methods, we can write different type of parameters. Okay, in case you don't have any parameter, you don't have any value to pass to the method, right? So in that case you can leave them blank. It can be with no parameters. Okay, and finally the method body that contains the instructions needed to complete the required activity, which is over here within these parentheses. We are going to write the code that is going to perform this method, the action to be taken by this method. Okay, now we have some example here. For example, you see this method, we have an access specifier public, return type void, the name of the method display with no parameters. And what does it do? It just display a message called welcome. Fine. So it's very simple. So I can write this method over here, for example. So let's say that it's a public method. Public does not return any value, and it is name is called display, right? And what does it do? It just write a message. Welcome to methods in C#. This is a method now called display that can be accessed by creating the object of this class program. By creating the object of this class program. Now, what if I want to access this method without creating the object? And I have to make this method as a static method. A static will come in the coming slides. We'll see what are these static methods. Now, public int product with parameters. So this is an access specifier, the return type, the name of the method. It has two parameters of type integer. It must return an integer value. What can be the integer value? For example, the product of two numbers. The name says product. It means we can have product of these two numbers and return this product. Okay. This is another method. Public int product or int x comma int y, the product of two numbers. All right. So I'll say int m is equal to x by y and return m. I'm returning this m. Okay. Now you see that this is a method. This is an access specifier, return type, name, parameter, its code. It returns some value, right? Now, access modifiers, commonly used access modifiers are public, protected, and private. Right? Public, it means you can access the method from anywhere, including outside the class. Just create the object of the class and you can access the methods. Protected, which the methods can be accessed inside the class and in subclasses. The children classes of the class where you write the method. Okay, this comes in the inheritance. Then private comes the method only, which is accessed only inside that class and not outside that class. Okay, so you can make the methods private. For example, this display is in public method, right? So I'll make it private. You can make it private. Okay, now this method is only accessible inside this class and it is not accessible outside the class program. Okay. Invoking the methods, how we can call these methods in our program. Now here, when we write these methods, right? Now, if I run this program, since main method does not have any code, you don't have any output. So if I run this program, right, I don't have any output. Why? There is nothing in the main method. The program execution starts from the main method, and inside the main method, there is nothing. When there is nothing in the main method, you don't get anything, right? What if I have in the main method, for example, console.writeLine welcome. I just have welcome as an output, right? Okay, what about these methods? Are they running? They are not executed. Of course, they are compiled, okay, but they are not executed. Why? Because these methods need a call, need an invoke. We need to make a call to these methods from the main method. We need to make a call to these methods, or at least some method must call these methods, which in turn must be called inside this method, inside the main method, so that we will call them and they'll do whatever the job is and we get the result. This is what we call it as an invoking methods. Okay, so the process of activating a method is what we call it as an invoking a method or calling a method. And this is done by using a dot operator along with the object name, the name of the object name of the class, object name dot method name with the parameter list. So in case, like if I want to use these methods, for example, I want to call these method display, okay, and I just simply say display. It's an error. It shows the name display does not exist in the current context. Okay, can I use the product of, let's say, 10 comma 20? It says our object reference is required to a non-static method, right? So I cannot use them. So how we can use them is, one way is that we can need to create an object of this program class. Our class is program, right? So program P is equal to new program. This is how we create an object, and I'll say that, okay, P dot display, and I can call P dot product. Now it is fine. This will work, right? Now when I run this, I have the output welcome to the methods in C#, which is from display. The first method to execute is display. So welcome to C#. The second method to execute is product. Now when we call this with 10, 20, 10 is passed to the X and 20 to Y, and then it is multiplied 10 by 20, 200, returns 200 here. So here comes the 200, but it is not printed on the screen because we did not print that, or we did not catch that return value into any variable and print it, right? So what we can do is that we can either take a result variable, okay, and print that result variable as console dot write line of the result. Okay, this is one way we can do that. That's fine, we will get that product here. Okay, other way is that we can simply directly instead of storing, we'll just say here P dot product. So whatever the value comes here will be here, and it will be printed by write line. Okay, now when we use these different things is that when we want to store these value, the return value, into a variable and perform other calculations to check the return value, to check what is the result, or to perform any other, we can simply take that into a variable, for example int result, okay, as a P dot product of 10 comma 20, and we want to perform some other thing, for example increment the result or decrement the result or use the result for other calculations, we can do like this. Or if you're just simply printing the result which is returned, we can directly print it by this write line. Okay, both the ways possible. So fine, so we use an object name here, right, dot the name of the method, okay, to call the method.
I have a question.
Yes, please.
To the program.
Yeah, please.
In the screen, we'll go back to the program. Yes, so but just I didn't understand. So if we write like 2 or 3 methods, and we want to display them, we will display them in the main method, right?
Yeah, we call them in the main method.
The calling, I didn't understand it. Will this program be equal a new program?
Calling the main method, you mean you did not understand calling?
The calling is why did we write program B equal a new program? This is the line.
This line is what we call the object creation. As I said, we write the programs here. These are the classes. We see that class program. Fine. Now, when we write these methods, These are non-static methods. It's not like a main method as a static method. We don't have a static keyword here. And if you recall the first meeting or in the second meeting when we saw the first program, we said static, it means we don't need any object to call these methods, static methods. Fine. So we don't have a static method here. These are all non-static methods. For any non-static method, whether it is in Java or it is in C#, when we want to call these methods, we need to create object of the class. How we create an object of the class is by this. The name of the class, the name of the object is equal to new program. This is called constructor. You will see, I think, this in chapter number 7, moving ahead. And even in this, we'll see at the end how we create the constructors. Okay, this is called constructor. This is called creating an object. We need to create an object of the class to use its methods. In the sense, if these methods are not static, if they are static, we don't need the object. For an instance, let's say that I'll make this method as static. Okay. Now you see here, it is a static method, right? We don't need the object here. I can simply call this method without using an object, and it works, right? And what about the product? Product is non-static method. I need this object to call this method. Okay, so this is the difference. And when we want to access any method which is not static, we need to create an object of the class in which the method exists by this way, and then we can call the non-static method. And in case of a static method, you can simply call them by the class within the class without creating an object of the method. I hope it's clear now.
Yes, it's clear.
Fine. So these are how we define. For an instance here, you can see we have a method called cube, right? And within a class called method. Fine. So you see this is one separate class where we have a method called cube, and it is non-static. This returns the cube of the value. Value is multiplied by 3 times, and it returns that value. In another class, in the main method of it, if I want to use this method, what I have to do is that I have to create an object of this method class by this method m. The name of the object is equal to new method with these brackets. This is called constructor to create this object. Okay, this is more like creating a variable int x is equal to 10, right? But here we need to use that constructor just to assign memory to this object. Now using this object m, I can call these methods. So I say that m dot cube of 5, this will call this method cube with the value 5. 5 is multiplied 3 times, and it returns that value here. It will be stored in y, and y is returned, which is the output will be displayed 125. Okay, so here it is the method call. Here we create an object. Here we call the method and store the result in a variable, and then we print the result here. Okay, this is how we invoke the methods. Now, in case we don't want to use the object and we just want to have a static methods in our class, then we need to add this static keyword after the access specifier. These are more same like your main method or a write line method. These are all class methods. When we write this console.writeLine, console is a class, right? You can see it is a class from system, right? And this console has this write line method. So this write line method is a static method. It is a static method because it is invoked by using the class and not by object. We are not creating object of console No, we are directly using the console, the name of the class and dot the name of the object. Okay. So similarly, if you add any method as a static method, for example, here I make this product as a static. I don't need this P now. This object I don't need because all my methods are static. I can simply call these methods without creating any object, without the need of the object, because these are all my static methods. So I can run them, it's fine for me now to work. Okay. So when we create an object is that when we have a method that is non-static method, we need to create an object and then we can call them. Okay. Fine. We also similarly, we can also have these variables as a static and non-static variables. If a variable is a static, you simply use this variable in the main method or in any method because it is a static and it is shared by all objects. The same copy 20 will be there for P as 20 for every object of the class, and everywhere you'll find that whatever the value you have for that variable, you will get that. What is the latest update of this variable? You will have that because it is static. When in case of A, which is non-static variable, this variable has to be with the object. The class is test. We create test t1 is equal to new test. T1 is an object. T1 dot A is equal to 10. So T1 object has a variable 10 with the value, sorry, has a variable A with the value 10. So it gets to, if I create, what if I create T2, for example? So if I create test T2, or let me show you here practically, in the sense, for example, I create here int A and I create here a static int B. Okay. Now in my main method, I create an object called P. Okay. Forget about display and all. And now if I want to use A and B, A must be used with the P because it is a non-static variable. Okay. So if I want to write the, update the A value, I can say that A is equal to 10. Sorry. A is equal to 10, right? It gives me an error. It says an object reference is required to the non-static field, which is a variable, right? So I have to use P here, P dot A, it works fine for me. Okay. And what about B? For example, B is equal to 20. It's fine because it is in static. Okay. So let us just print now console.writeLine of, I want to print the A and B. Okay. And A and so A should be with P dot A. Okay. So it works for me 10 and 20. Okay. Fine. Yes.
As a programmer, why would I use like private or public methods? I will use only static. It will be easier for me.
Okay. Now static, whenever we create, see, object creating is not every time we have a single object. For an example, let's say that we write a class called a student. As a programmer, you are in a programmer team. I mean programming team where in the development team where you are a programmer and you have a task of writing the SIS software, okay, or developing the SIS software. Now there is a class called a student that you need to write, and there is number of operations you have to do with the student class. And a student has a number of data. It has an ID, email, and name, and national ID, and so on. What do you think? Like how you store these every different student. Let's say, for example, in KSA we have 10,000 students. How do you create objects of this? And when we write a class, we write in common a class student, and we define the common variables for every student: ID, name, national ID, passport number, for example, email, and so and so and so. And we define a number of methods which are common to every student: registration method, add and drop course method, add course, drop course, calculate GPA, or all other different methods, right? When we do this, for example, we need to keep some methods private inside the class, because we don't want these methods to be accessed outside the class. Because, for example, let's say that we have a method called in the inner class method. We don't want this to be accessed outside the class. We'll keep them private. For example, calculate the semester GPA. Semester GPA should not, and let's say that we don't want this method outside the class. We'll keep them private. Number one. Number two, we have 10,000 students, right? Every student has its own ID, on X. Everything is its own, right? Your ID is not same as other student ID. We have to keep them every student different ID. We have to keep every student has different name, every student has different national ID, and so on and so. Now, in this case, what do you think that we need? Can we store that in one ID, all these IDs? We cannot. Every student now acts as an object. Every student here is an object. In the sense, for example, yourself is an object. You have your ID, you have your XYZ. Another student, for example, let's say Ahmed is an object. Abdullah is an object. Abdurrahman is an object. Abdullah has its own data, Abdurrahman has its own data, everyone has its own data. For example, let's say that here I create another object, program P1 is equal to new program. Now P1.a is equal to 20. What do you think? P.a and P1.a, they are different or same?
Different, because
They are different. P is a different object, P1 is a different object. You as a student, a different object. Your friend, for example, Ahmed, is a different object, has its own, right? So that's why when we write any class, right, as a programmer, when we write any class, we write that as common. And from this class, we create objects of it. So we have a student class, right? And from this student class, we create every student. We can create 1,000, 10,000, 1,000, 1,000,000, 1,000,000,000 objects, no matter. Every object must take a different value. So by creating the object, we assign them these variables, we assign them these methods, and we work with that. So we'll see that here, for example, let's say that P.a is 10, P1.a is 20. Now if I say P1.a, what I will get? I'll get 20, right? Not 10. So that means more specific. So that's why we need to have something like this, where we create the objects, where we write different methods to work on these objects, and then we'll create objects of these classes and make use of these objects as an instance of a class to work with that objects. Okay, this is why we need all these kind of thing.
Okay, thank you.
Okay, since we are at the beginning of the programming, so we are, yeah, might be we think like why we need this, why we need that, but these are used when we write big programs. Okay, so we have to give you the concepts here at the beginning, right? So that you will be okay with coming programs, right? If you go advanced in this, you will be okay with that. Okay. So this is what the difference between a static and non-static variables or methods. Okay, static, it means we can access them within a class without creating an object, whereas non-static we need to create an object. Okay, for an instance, we have a static method called product here that returns a product of two numbers, right? So we don't need to create an object of it, object of the class. Simply we just use the name and we call that. Okay, similarly we have a static square method, takes a square of the, it takes a float variable, float value, and print the square, I mean return the square. We can simply print the square of the numbers. Okay, now here we have some examples. Create a function called static function called add that accept two numbers from the user and print the sum. Now this function takes the values, right, you know, calculate the sum and print the sum. Everything is done inside the function only, right? So how we write it is simply we declare the variables, static variables, number one, number two, and result. We write the method public static void. Why void? Because this method is not returning anything, right? So we use void. We call there is no parameters because we are going to ask the user to enter the values, right? So there is no parameters here. Now the method body is like this: enter the number one, enter, we read that first number, enter the second number, we read the second number, calculate the sum, print the sum. This method is closed here. Fine, the method is okay. Now how I invoke this method? Since it is a static, I don't need to create any object of this class. Simply I use the name of the method. In my main method, I just say add. This will invoke this method and it starts the execution from here, asking you to enter the first number. You enter the first number, then it will ask you the second number, enter the second number, just add these two numbers, it will give you the result sum. I mean, when if this 73, I think, yeah, 73 will be printed. Sum is equal to 70. And the method finishes its job. It comes here and see there is no more code. The program is gonna terminate here. Okay. Similarly, we have another example here, static function big that accept two numbers from the user and print the biggest of two numbers. The same thing, just read these two numbers, check the number one is bigger than number two, print the biggest number is number one, else biggest number is two, else both are equal, finish. How we invoke in the main method, we call big. The big is, will call this. It will ask you to enter these two numbers. You enter these two numbers, then it will do check the first number is greater than number two. If it is true, it will print number one is bigger. Done. And it will come to the main. There is no more code to execute. Will terminate the program. Okay, simple. Now, the next thing here is something called pass by value and pass by reference. We have seen these examples here, right? The static methods and all, how we create the non-static and the static methods and non-static static variables. Okay. Now let us understand the new concept here called pass by value and pass by reference. What is this pass by value and pass by reference? When we call these method which has some parameters, you see these parameters. When we call these methods, we are going to pass the values to these methods. Okay. Now, for example, let's say that I have two variables here. Int number one is equal to 10, number two is equal to 20. Okay. Now, I'll write a method here called public static swap of int x comma int y. So what is this method is going to do is that it will swap the two values, x to y and y to x. So I'll take int t as x, and I'll say x is equal to y, and then I'll say y is equal to t. Okay, the swapping is done. Fine. Now I'll call this swap method from here, swap of. Now let me print the first console dot write line. What is my n1 number 1 is equal to the first value, comma number 2 is equal to the second value. Okay, n1 comma n2. Fine. So what is the output of this program now? It will just display me n1 and n2, right? n1 10, n2 20. That's okay. Now let me call swap of n1 comma n2. n1 is 10, n2 is 20. We'll call this swap method and we'll pass here 10 and 20 to xy. Now we are going to swap this xy here, right? After the swapping, I want to check again the n1 and n2 whether they are swapped or not. What do you think? It will be swapped or not?
Yes.
Swapped?
Makes sense. Yes.
It will be swapped, right? Should be swapped, huh? Yeah. There is a magic here. It is not. It will not be swapped. It will be same. Why? This is what we call pass by value. Pass by value in the sense when we call the method and we pass the values to the method, it takes the copy of n1 and n2. n1 is taken here, n2 is taken. What it means? 10 is given to x, 20 is given to y, and swapping is done here. If I print here x and y, console.writeLine of is equal to the value. Just take this. And this is y, and this is for x, and this is for y. Okay, and this is inside the method in swap method. What is x and y? Okay, and then after swap here, after calling swap, you can see here now there is some error here. Input string was not in a correct format. Okay, stop this. Now n is 10 20 initially. In swap method x20 and y10 there is a swap. After calling swap, n remains same. What does it mean? It means that it takes the copy of 10 and 20 here to x and y. Swap happens inside the method, but it does not affect the value of n1 and n2 because it is what we call it as an pass by value, where we are going to pass the values value of the formal parameter can be changed within the method, but the value of the actual parameter passed by value to a method is not changed by any changes made in the corresponding formal. Actual parameters are these when we call this swap, right? This is the actual parameters and these are the formal parameters. So value will be given to x and y, and whatever you do inside the method will do only to these and will not affect this. This is what we call pass by value, right? Clear? Is it clear? Before I go to pass by reference. Students, is it clear or?
Yes,
Okay, fine, great. Now, pass by reference. What we want this to be in opposite. I want this, whatever I make the change to be happened here, then I can do it by using something called reference, the reference of the variables. What is this reference of the variables? This is, we are passing the reference here. You can see I have to use ref as a reference. I am passing the reference of n1 and n2. It is not I am copying the values. No, I am passing the reference where the values are present in the memory, right? Now you can see that n1 and n2 is also swapped. You can see n1 is 20 and n2 is 10. This is what we call pass by reference. So what happens in pass by reference is that, for example, this is the memory where I declare two variables, right? N1 and N2. So N1 is this, N2 is this, 10, 20. Okay. When I call swap of N1 comma N2 without reference, what happens? What is the value of N1? 10, 20. We'll go to the swap method. Let's say here we have that swap method. Okay, it takes int x comma y, int y. So 10 and 20, 10 here, 20 here. You do whatever you want in the swap method, will not affect n1 and n2 because you are doing for x and y. X and y is somewhere here, for example, x and y, 10, 20. So whatever you do swap will be affected here, and this remains same. Right? This is in pass by value. Now what is in pass by reference? In pass by reference, when I say swap of reference of n1 comma reference of n2, I am giving the reference of the memory where the values are stored. When I call this, when I have this swap method here with int x, reference int x and reference integer y, I'm giving the reference here. So that means x is referring to the n1 value here in the memory, y is referring to the n2 value in the memory. Whatever the change I make for x and y will affect here. If I make a swap here, will affect 20 and 10. This is also affecting to n1 and n2. Okay, this is what we call it as in pass by reference. This is what is happening here. Pass by reference. Okay, so these are two concepts we have in methods, pass by value and pass by reference. So we are going to use this reference here. Okay, for example, this example, changing the m, x value is 100, change, we call the change with the reference of x. We'll take to the m, add 10 to the 100. Okay, and when we print x, we get 110. Why? Because it is changed, 10 is added here, and we call them as pass by reference. Okay, so swapping, yeah, here it is a swapping method, what I just explained you, right? So with a reference. Okay, this is what we call pass by reference. So is it clear, pass by reference and pass by value? Is it clear?
Yes, clear.
Okay, moving ahead to another concept of in methods, which is called method overloading. Now, this method overloading help us in writing methods, similar methods with the same name, okay, but with different parameters. For example, let's say that you want to write a method called volume, volume of a cube, volume of a cylinder, volume of a box. Volume of cylinder cube is different, volume of float, sorry, the cylinder is different, volume of a box is different. Okay. Similarly, if you want to say, for example, you want to write a methods to calculate the area of a geometric shape, area of circle, area of rectangle, area of triangle. Okay. In that case, every area takes different parameter. Area of circle takes radius, area of rectangle takes length into width, length and width, or height and width, right? So the same name but takes different parameters. This option allows this for this we have an option, or we can say a facility in programming called method overloading. We can write similar methods with the same name but with different parameters. The parameters should be different. We can see here this volume method has only one parameter. This volume method has two parameters, and the third volume method has three parameters. Now, when we call these methods, how these methods are differentiating? If I call the volume with only one integer value, this will go and check where is that integer value method. It's here. It will call this and execute this and return cube of a number here. This returns a cube of a number here. If I call this with one float value, the other integer value, volume with 2.5 float and integer, this will go and check where is this. It's here. No, it's here. Yes, it is here. Giving this 2.5 to R and 8 to the H, and calculate this volume and return the volume to print here. When I call this with three values, one with a long integer value, the other is an integer, the third is an integer, it will go and check where it is. It is here. Yes, 100 is given to L, 75 to B, 15 to H, multiply all of them and return the volume here. Print it. Okay, so the mapping is done based on the number of parameters and the type of parameters we have. Okay, so this way we can write methods with the same name but different parameter list, and the invoking of the method depends on the number of parameters and the type of parameters and how they are arranged or how they are added. This is called method overloading in programming. Okay, so we have another example here, overloading the sum method. Sum with no parameters, sum with two parameters of type integer, sum with two parameters of type float, sum with a string. Okay, so we have four methods with the same name: public static void sum, public static void sum, public static void sum, public static void sum. But their parameters, one has no parameters, the other has two integer parameters, the third has two float parameters, the fourth has one string argument, string parameter. Okay, same name, different parameters. This is what we call method overloading. Now, when we invoke these methods, the mapping is done based on the parameters. For example, if I call sum with no parameters, this will be invoked, and what it writes, no value provided on the screen. If I call sum of 5 comma 4, 5 and 4 is integer values and not float, right? So 5 and 4 integer will go for this x5, y4, 5 plus 4, 9, you will get the output. If I call this with float value 9.3f, 8.6f, f means float. This will invoke this float with x 9.3, y 8.6, sum of them printed here. When I call sum of hello world is a string, right? So it will go for this string. It's not a numeric value, it will be printed. Okay. So the invoking or the mapping is done based on the parameters list, and this is called method overloading. Okay. The next is the constructor concept. C# provides a special type method called constructor that enables an object to initialize to itself when it is created. Is that constructor I created here. Program P is equal to new program. This is what is called constructor. Constructors are used to create the objects and to initialize the objects, to initialize its object values. Constructors are more like similar, like we can write them like methods, like for example public program. Okay, this is my constructor. Okay, these constructors are used to construct the objects, to create the objects and to initialize the value. For example, let's say that a is equal to 10. Okay, when I create p, the a value, let's me write this console dot write line p dot a. When I create an object p here by calling this constructor, this will call this constructor and set the a value to 10 for p. So p dot a will get 10. Okay. 11, for example, p dot a will be 11. So this will be the initial value for any object will be created by using this constructor. This is what we call constructors. These are more like methods having same name as class name and does not have any return type. They are not static and does not have return type because constructor never returns any value. So that's why there does not have the return type. Constructor have same name as the class name, which is program. The class is program. Secondly, they do not specify return type, not even void, because they do not return any value. Okay, constructors are created by like this. Okay, this is just to test that object is created. When we create an object, you can test that when the p is created, this constructor is invoked. Constructor is invoked. So you can see here constructor is invoked and then we have the p value, sorry, the a value for p, right? Any number of constructor you create, for example, you create p, right? Here I want to create p1, p2, p3 like this. For example, I create here p1. Okay. I'm not printing here, let's say. Your two constructors are created, p and p1. Okay, both p and p1 will get this a value as 11, the initial value. This is what is called the initial value for the variables. Later, p1 can change the a value and p can change a value. Okay. We also have something called destructor to destroy the object. This destructor is same as constructor but preceded with a tilde operator, which is like this. This is to destroy the object. When we call the destructor, it will just simply delete that object. Okay. More about constructor and destructor will be covered in unit number 6, will be in the next class. Fine. So this is all what we have for you in this chapter 5 called methods. So we saw here how we write the methods, how we invoke the methods or call the methods, the static and non-static methods, passing parameters to the methods, two ways, pass by value, pass by reference. Then we saw method overloading, and we just read about constructor and destructor. So this is all what we have for you in this method chapter number 5. Okay. Any questions? Please go ahead before we move to the chapter number 6. Any questions? Quickly, we don't have the time, please. Any questions?
Not of the questions for me.
The lab will be starting after Asr prayer, inshallah. We'll see, like, after we pray Asr, inshallah, we'll do the lab. Okay. I need to cover this arrays topic, and then after that we'll see in the lab. Okay. Fine. Chapter number 6 is about arrays. We'll do one thing. Let's have a break for like 5 minutes. Okay. And then we will continue. What do you think? Anyhow, we have the lab session together. We can continue up to 4:30. Right? That's great. So let's have a break of 5 minutes, and we will be back. Let's say 3:32. Students, welcome back.
عليكم السلام ورحمة الله.
Okay. So the next topic here is arrays. Let me put this on recording. Okay. Fine. So we'll discuss about arrays, what are the arrays and how we use arrays in our programs. So an array is a group of contiguous or related data items that share a common name. Or in simple words, we can say an array is a variable having same name and same data type that can store similar type of values. Same type of value. For example, we can have an array that can store integer values. So that means that array will store all integer values. Okay, different integer values it can store. And it has only one name, one common name. Right? So an array stores a fixed size sequential collection of elements of same types. Array can be of any variable type. It can be integer, it can be float, it can be double. But once it is created, the size is fixed. For example, once you create an array with the size of 10, that means that this array can store 10 values. And you said that this is an integer array, that means it can store 10 integer values, and the size is fixed. Once it is created, the size is fixed. You cannot shrink that array, or you cannot expand or that array. Okay. So suppose that we want to store 10 marks of a students in a class, then instead of declaring 10 different variables, 10 individual variables like mark 1, mark 2, mark 3, we can declare a variable called array and use the index like mark of 0, mark of 1. This represents the first mark, this represents the second mark, and so on till it represents the last mark, okay, of individual students. The mark of a specific student is accessed by the index number. For example, student 1 with the index 0, student 2, student index 1, and so on. Okay, while complete set of values is referred to an array, the individual values are called elements in the array. Every individual value is called an element. Now, the ability to use a single name to represent a collection of items and to refer to an item by specifying the item number enable us to develop concise and efficient programs. So wherever we want to store a set of values, right, and we can access similar type of values, and we can access those values by the index. This helps us in our programs to store such kind of values, okay, a list of values or a set of values of same type. We can also use, for example, a loop that can go through all these values one by one, okay, by using the index. And we can perform the calculation on these arrays. Now, arrays, we have two types of array, one-dimensional array and two-dimensional arrays. We'll see, inshallah, what is this one-dimensional array and then what is a two-dimensional array. Now, one-dimensional array can store a single list of values of fixed size. So list of items can be given a variable name using only one subscript, and such variable is called a single subscript or a one-dimensional array. So subscripts begins with a zero, number 0, that is the index begins with number 0. For an example, if you want to store a set of 5 numbers, which is let's say 3, 4, 2, 5, 1, by a variable name called number, then we can create an array by name number to store these number of values. How many values we have here? 5 values. So we can create an array something like this, int these brackets, you see the square bracket, tells the compiler that this number is an array. Okay, so this part is just a declaration of the array, and then this is allocating the memory allocation. New way operator will allocate the memory for integer 5 values. This is the size of the array. Okay, this can be written in two parts. One is declaration, and then we can do the initialization, or we can say that allocation of the memory. Okay, so this way we declare a number as an array by saying this square brackets after the data type, and its type is integer, okay, and the size is 5. Okay, store 5 values. So how this will be in the memory? We have 5 different memory locations, okay, reserved for the size 5, right, reserved for 5 integer values. 5 integer values. So now the array number of 0, this is the index number, number of 1, number of 2, number of 3, number of 3. These are the elements where and this is the memory where we can store different values. And we can assign the value by using these indexes. Like for example, number of 0, here 3, so 3 goes here. Number of 1, 4, 4 goes here. Number of 2, 2. This is 2, yeah. Number of 3, 5, and number of 4, I think, what is number 4? 1, so it is 1 here. Okay, by these assignment operators. Right. So we'll be having something like this. Number of 0 is 3, and we can also access this same in the same way. So for example, if I say console.writeLine number of 0 will print me 3. Console.writeLine number of 3 will print me 5. Console.writeLine number of 4 will print me 1. If I do number 4 plus plus in the code, this will be incremented to 2. Okay, this is acting like variables. This is a variable for this memory, this is a variable for this memory, but with the same name but different index. Same name, different index. Okay, so what are the steps to create an array? First we declare an array, then we create a memory locations, then put the values in the array. How we declare an array? Let's take this out. How we declare an array? Int the array number. This is declaration. Array declaration. Okay. The first step. Just 2 minutes, please. Is array declaration, and now the second step, it says create memory location with the new operator. So we say number is equal to new integer of what is the size of the array, for example 5. This is the second step, which is memory allocation. Okay, now the memory array is ready. Now we can use this array as initialization. For example, number of 0 is equal to 3, and number of 1 is equal to 4, so and so on. So it goes by index, right? It goes by index. So we have the index. For example, if the size is 5, we can have index from 0 to 4. So I can have up to number of 4. Number of 4 is equal to 1, for example. It works fine. What if I take number of 5 is equal to 20? Now here, this number of 5 will not work. So if you say, for example, console dot write line number of 1, this works fine. Why? Because number of 1 is 4 and within the index. So still there is a problem here, which is that there is index here, okay, which is wrong, number of 5, because 5 there is no index. We have only 5 elements. It means 0, 1, 2, 3, 4 up to index 4 and not 5. Okay, so this is not there, but number of 4 up to 4 it works fine. Number of 1 I am printing, which is 4, will be printed. So I can print number of 4, which is 1, will be printed. What I go for 5, this is an error. This is index out of bound exception, index outside the bound of the array. This is called an exception or an error. Okay, fine. So that means I can have the index from 0 to the size minus 1. Size is 5, 5 minus 1, 4. Okay, putting the value in the memory locations. So array declaration by the type, the array, and the name, what I declared here. For example, int the array counter. So this is all the declarations. Okay, this is declaring 2 arrays of type integer, but you have to give the memory location in separate. If you declare 2 arrays, for example, int number comma x, so x is also an array now. Here, for example, x is also an array. Okay. For declaration, I have made for number, but not for x. So what if I say x of 1, right? This is an error. You say that local variable int x, it is unassigned local variable x, right? I need to assign it like x is equal to new integer of, let's say, 6. Okay, now it works for me. It's okay, but I did not initialize any value. So if I did not initialize any value, it is 0 by default. Okay, because it is an integer, it is 0 by default. So I can assign the value x of 1 is equal to 10, so that 10 will be printed for me. Okay, so since we have the size 4, I can have the index for x from 0 to 5, size minus 1, that is 5. 0, 1, 2, 3, 4, 5. So 6 values. So, okay, this is a creation of the array. And we can put these two statements in one, like this, instead of putting these two statements like in separate. If I want to have in one, we can have that in one statement. Like for example, this one, creation as well as the memory allocation is equal to new int of 5, this way. And in this case, we don't need this statement. Okay. X is not there. Here both creation and declaration are done in one line. This is also true. We assign the value by using their index. And the other way we can assign is that if you know the value, we can simply directly assign at the time of declaration. So how it is something like this. Take out all this and just say like at the time of declaration, int number is equal to 3, 4, 2, 5, 1. Okay, this is fine. Can assign this. So this is assignment during declaration. So I can say, for example, number of 0 is my first value, right, which is 3. Number of 1 is this, number of 2, number of 3, number of 4. You can assign like this any number of values. This is, we can initialize the array when we declare an array. Now coming to the length of the array. Length of the array is the number of elements in the array. Okay, what is the allocated size? The variable length. You can print the length of the array by using the array number dot length. So this will print me what is its size. It is 5. See, 5, because we have 5 elements here. Okay, and what if I initialize it like new int of 10, right? What is the length here? 10. This is the length variable of the array. We can get the length of the array, right? So now this is an example where we are just declaring an array, assigning its values and printing the values by using a for loop. For loops are the best to process the array. Any array you want to process, for loops are best. For example, int marks is equal to, I'm just giving some marks here. Let's say for example 100, 37, 57, 89, 90, 99. Okay, so these are some marks here, and I want to print these marks, all the marks. One way is that I write marks of 0, marks of 1, marks of 2, 3, 4. The other is I just simply write a variable, write a for loop starting from 0 and less than the number of elements. I don't know, when I don't know number of elements, I can simply say marks dot length, because that is the number of elements, and increment it. Okay, and just write console dot write line the mark of I. Sorry, this marks of I. I is index here. Index starts from 0 and goes till less than the length of the array and increments every time, printing the, so I0, I1, 2, 3, so it is I0 100, I1, 2, 3, 4, 5, it goes up to 5, okay, which is less than the length. The length is 6, 5, less than the length, okay. Now this will simply print all the elements. You can see there's 100 first, 37, 57, 89, 90, 99, okay, by using the for loop. We also have another type of loop called for each int I in marks. Now what is this? This is more similar like what I wrote just. In this case, in for each loop, it takes one by one and assign to I, okay, and I just print here I and not marks of I, okay, because it takes first 100 to I, then 37 to I, and so on. You can see here now, okay. The first method what I used, the for loop, instead of for each loop I use a for loop, right? I write both for you. This is one for int I is equal to 0, I less than marks dot length I plus plus, right, and so dot right line of. Now here I have to use marks of I because I is an index here. Here I is not index, I is the element itself in for each loop, okay. Both the way you can process the array, you can go through the array one by one, okay. We have another example. For example, if I want to find what are the even numbers in this array, even numbers are nothing but if I divide that number by 2, I'll get the remainder 0. So I'll put that condition, and if this condition is true, I'll print the element, okay. So for example, like here, forget about this, in for each loop, for example, or let me take this and keep this for later, for each loop. Now here I want to check that what are the even numbers, okay. So I will say if the marks of I divided by 2 modulus by 2 is equal to 0, then print that array. This will print me only the even numbers like 100, 90, only two values it will print for me, 100 and 90. And if I want to print the odd numbers, there is the remainder is 1, then it prints me odd numbers 37, 57, 89, 99. Arqam al-zawji, arqam al-fardi. Okay. Now here we have a program called sorting program. We'll take an array and we sort the array, right? We are using here sorting, which is called bubble sort, where we take every element and compare with other elements, and wherever we find the element is less than comparing elements, we just swap that, okay. 55 is compared with 40. If it is 40 is less than 55, we are going to exchange it, and then compare with 10, exchange, then compare with 5, exchange, and then compare with 2, exchange, and so on. This is repeated for number of times, okay. So in this case we use two for loops, one for the steps, the other for comparison, okay. So and inside that we are going to do swapping. If the number of I is less than number of j, we do swapping, okay. And after we do swapping, we'll have that sorted list. When you print, you'll get that sorted list, okay. Now try this program at home with these two for loops, okay. This is a sorting program, okay. Now we can pass the array to the methods. Pass the array to the methods, okay. Like just as in parameter, we have to mention that the parameter we are taking is an array, okay. And we can use that array inside. For example, here we are printing the array, okay. So in the main method we create an array with the values, and we call this print of P. P will be given here, P will be printed, and once the printing is done, the program terminates here. Okay. Now we can also pass the array as a reference, pass by reference, the same way how we pass the values. Okay. So when we pass the reference, the original array P will be affected, like we did. We check in the previous chapter, in chapter number 5, that is pass by value and pass by reference. Okay. Similarly, for arrays, there is a pass by value and pass by reference. Okay. So this is about a one-dimensional array. So to process any one-dimensional array, what you need is a for loop. Through the for loop, you can process the array. For example, let's say that this is the marks, right? I want to calculate average of these marks. Then how I can calculate? For that, I need to sum all these marks, okay, and then divide by its length, right? So what I'll do here is that in the for loop, inside this for loop, I'm gonna sum every element. Sum is equal to sum plus the marks of I. I'm adding this every element to the sum. So after I get the sum, I can calculate the average, right? So float, let's take double, average is equal to sum divided by the array, which is marks dot length, is the number of elements, right? So I'll just write console dot write line, the average of marks is average. What is this? Okay. So I have the average as 78. For me, the average, what it will do, it will sum up all these, and here it comes after summing up to calculate the average, and it is printing the average, right? Similarly, if we want to find what is the greatest of all these, we can write the code here to find the greatest of all these. Sorting the array, 2 for loops, one for I, the other we have to write for j, for int j is equal to I plus 1, j is less than the array dot length, that is marks dot length, j plus plus, and inside this we can swap the array, the elements here based on what we want to do here. For example, swapping is done here by checking the condition, okay, and sorting can be done by using 2 for loops. Similarly, anything like you want to process the array, we use the for loops to process the arrays. Okay, sum, average, and finding odd values, even values, we need a for loop. So that's about one-dimensional array. Now moving ahead, we have two-dimensional arrays. Two-dimensional arrays takes two index or two indices. In one-dimensional array, we have that is one dimension or one index, right? Like in the sense here a of I. Whereas in two-dimensional array, there will be two indexes, one for row and one for column. So two-dimensional array is more or like table or a matrix. We have the rows and we have the columns. Right? For example, you have a matrix here or a table with 4 columns and 3 rows. We want to present this in a program. We can use two-dimensional array, one for rows, the other for column. Okay, so it will be like 2 dimensions, one rows, comma, column. Okay, So how we can declare this two-dimensional array is very simple, the same way, but just need to add a comma here. And while assigning the memory, we assign number of rows and number of columns. 3 rows, 4 columns. So it will be like this. We have 3 rows and 4 columns. Column 1, column 2, column 3 and 4. Row 1, row 2 and row 3. So this is 0, 1, 2 rows and 0, 1, 2, 3 columns. Okay, and we can assign the values like this is row 1, this is row 2, row 3. So it is 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, 2, 2. Okay, every row in brackets separated by comma. Okay, fine. So this what is called a two-dimensional array. We can use two-dimensional array for multiplication tables, for matrix. Yes.
The last row, they didn't put a comma or some mistake on the slide.
For the last row, there is no comma here.
Yes.
Yeah, this is not required because this is the last row, right? Okay. This comma is separating the rows. Row 1, row 2, row 3. Okay. Fine. So here if you see this multiplication table program, we have 20 rows and 20 columns. I create a product matrix or a table with number of rows and columns. So here it is 20 and 20, right? Because it is 20 and 20. Now multiplication table is what is just in multiplication. We store this product of ij, I for rows and j for columns. So it will be like, for example, table, with how many rows? 20 rows. It goes like this, 20 rows and so on, and 20 columns like this and so on. So this is row 0, 1, 2, 3 and so on. This is column 0, 1, 2, 3 and so on. So when we start with I, it is starting with 10, right? Let's take starting with 0 and this is starting with 0. So when it starts with I0, 0 less than 20, it comes in J0, 0 less than 20, then it says product of I comma j, 0 comma 0. So it is 0, 0 is equal to multiply I and j. 0 multiplied by 0 is 0 here, right? Then it goes again, done, goes for the j plus plus, because it has to finish the inner loop to go to the outer loop. The inner loop is not yet finished. So j is 1. So I0, J1, I0, row 0, J1, it is 0, right? 0 by 1, 0. Again, it will increment J will be 2, I0, J2, I0, J2 is here. Okay, and it goes on in this way. Fine. So let me just show you. It's very simple. Okay, let me just copy this code so it will be fast enough. So rows and columns we need to define, int rows is equal to 5. I'll put 3 cross 3. Okay. Columns is equal to 3. So it is 3 cross 3. Sorry, it should be static. Used here. So now you can see that it's in the form of matrix. Where are the values? It's not printing any value. Oh, it's starting from 10. There is no 10 here. So now you can see that 3 cross 3, 3 rows and 3 columns. The first row 0, 0, then 0, 1, 2, 0, 0, 2, 4. right? So the first row, then it goes for all columns in the first row. Then once the J loop is finished, we'll go to the I again, second row, all columns. Then it will go to the third row, all columns. Then it will go check for the I. When I is false, like 4, there is the rows is only 3, so it comes out here. Okay. So anything message here, let's say for example console.writeLine, done. Okay. That will be printed at the end. You can see here. So it's very simple that we use it here, two-dimensional array for tables or for matrices. Okay. For example, addition of two matrices, right? Subtraction of two matrices can be done by using this two-dimensional array. Right. Moving ahead, a system array class. The C# provides a derived system class called array class, which has a number of methods that we can use for our arrays. So we have these number of methods, what you can see on the screen. We have clear, copy to, get length, get value, these methods. Okay, sort, we also have the sort method where we can sort the array, for example here. So if you see this program, for example, we have this array, right? We print this array before list sorting. Then we call this sort method of the array class on this array X. What does it will do? It will sort this array. Then we call the reverse method. What does it will do? It will reverse the array. Then we are printing again. So you see that here this is sorted and reversed. The output is here. So from where these methods comes? These method comes from the array class of the system. Right? So we can use that in our programs. Right? We also have another type of class called array list class. Now why we need to use this array list class when we have the array facility? This array list class is more like array, but this is a dynamic array. Dynamic array in the sense, when we create an array, for example, let me here for you. I'll just copy this example here for you. What happened to this? Okay. So I have an array here. Fine. So this array, if I want to print this array, I'll use this for loop, for each loop, for each of the element I in the X. Okay. And I want to print it. What is this? I took out the main method. So it should be in the main method. So this is my array. So I'll use for each of integer I in the X array. Right, I'll just write console.writeLine the array. Okay, so this is printing the array. Fine. If I want to reverse this array. So I'll say array dot reverse of x. This will reverse the array, right? You can print it again after reversing. You can print and see. The first one is this to 20, and now this is reversed. Okay. Similarly, we have sort and so on. Okay. Now, when we create this array, what is the size of this array? 1, 2, 3, 4, 5. 5, right? 5 elements. Okay. We cannot add sixth element because it is fixed size. Okay. Now, what is this array list? Array list is a class with dynamic size. Dynamic size in the sense we can create an array that can be extended. The size can be extended. It can shrink or it can extend the size. Okay, dynamic in size. That is in the array. So okay, so the system collection namespace defines a class called ArrayList that can store a dynamic size array. We have a number of methods, for example, add, to add an object or an element to the array, clear, remove all the elements, contain, copy, remove at position, sort array, capacity, count the array, number of elements. Okay, capacity is different, count is different. Capacity, the number of elements in the list. Count, what is the size of the list. Okay. For example, I create an array list here, n, the new array list. We have to create an object, like an object. Add these values. Okay. So this array adding what? The string values. Then what is the capacity? What is the count? Okay. Capacity is the system defined that this array list n can store how many values. Count, what is the values currently present. 1, 2, 3, 4, 5. Count is 5. Capacity can be anything, 5 plus 10, 15, depends on the system. Okay. Then we can sort the array. We can use the index to print the array. Like the array we printed, we can use the index to use the print array list. We want to remove the element at particular location, we can remove that at particular location. Okay, and so on. So you can see that capacity is 16, element present is 5. This is the count and this is the capacity. Capacity is system defined. In this way, we did not specify any space here for the array, but the initial capacity given is 16. What if we go beyond 16? It will automatically add more 16 or any other number. Okay, so when we want to store more values, it will automatically add here. That's why it is dynamic. Fine. So we are printing all this and we call here remove. You see remove at 4. At 4, 0, 1, 2, 3, 4, Madras. Madras is removed. Now we print again with removing Madras. Okay. So this is array list. So there is a difference between array and the array list. The array list is a dynamic in size. In the array list, you have different methods like add, clear, okay, remove at position, and all. Okay, and array is dynamic in size. This is the main difference: dynamic in size, in their size. Okay, you can add any number of elements. You can remove the elements. There is no worry about the size. Whereas in array, you need to take care of the size. Fine. So this is about the array list. Fine. So this is all what we have in this chapter for arrays. We discuss about one dimension, two dimensional array, and the array list class. Okay. So this is now here. If you have any questions, please go ahead. No questions? Fine. Okay, we have the lab session. We'll just complete the lab session here. I think there's no one in the lab link. We'll complete the lab session here. I'll just take 10 minutes break. We'll pray Asr, and then inshallah we'll complete the lab session here. Okay.